So in just the last video we tried to implement the quicksort function and we compared this quicksort function with all the other functions. Okay, so that is, we have taken all the other algorithms, that is insertion sort, selection sort, merge sort and bubble sort. So bubble sort, we have not taken the merge sort algorithm. So in this video what we will do is we are going to take that merge sort algorithm and we'll try to see how we implement the merge sort algorithm, and then again we are going to compare all these 4-5 algorithms according to their execution time. So again we'll go to file and we are going to create a new file which will be C++ source file. Go, you can see this writing program is C language, so I'm just going to give the program as merge sort. This is a merge sort function. So let us start writing the merge sort function, but before that you need to understand what is a merge sort function. For merge sort function we have to use two procedures. First of all we have to use a merging procedure, which is a merge procedure, and using this merge procedure we are going to do the merge sort. Okay, so let us write the merge sort function. So merge sort function will be like this. We are going to take the array A as input, we'll be having P, we'll be having R. This is an array. Now if P is less than R, then we are going to find the middle point between P and R. So we are going to take Q is equal to P plus R divided by 2 floor value, and then I'm going to call the same function, that is merge sort on A, P, Q, and merge sort on A, P, Q plus 1, A, Q plus 1 to R, and then I'm going to call merge on A, P, Q and R. So this is the merge sort function, and in this merge sort function the major role is played by the merging procedure. So what is this merging procedure? Because to implement the merge sort function initially we have to implement the merging procedure. What is a merging procedure? Given an array like this, now we'll be knowing that from P to Q the data is already sorted, from Q to R the data is already sorted, and now we have to merge this data inside the same array, or you can also take an extra array. So see, there are a lot of different implementations of merge sort function which are available. Either what you can do is you can copy all this data into a new array like this, and from these new arrays you can copy the data back to the original array. This is one kind of implementation. Or what you can do is, if this is the array which is from P to Q, it is already sorted, from Q to R it is already sorted. Now you can take entire one more array, and after taking this entire one more array you are just going to take pointers and you are going to merge these values inside this new array. So this is also how you can implement the merge sort function. Okay, so anyways, I'm just going to use this one because I've explained this kind of function in the preliminary course. I'm just going to explain this one and we are going to implement it. Okay, so let us do it step by step. It will create the structure of the program. So we'll be using hash include stdir.h, that is our header files, and then I'm going to write the merge function. So there will be a merge function which is going to take integer A as input and integer P and integer R, A, P and R, right? So this is A, P, Q and R because this merge function takes all the three values, which is A, P, integer Q and R. So it takes all the three values A, P, Q and R, and it does not return any value actually. So because as we have done the partition procedure returns a value, but the merging procedure does not return any value. Now we are going to also create the merge sort function, which is ms, and it's going to take integer A as input, integer P, comma, integer R, and then we're going to say if P is less than R, so we have to find the middle point on this. So Q is equal to P plus R divided by 2. Q is equal to P plus R divided by 2, and then I'm going to call merge sort on A, P, Q. So why I'm not taking any floor value here? Because automatically q is a integer variable, so it is just going to ignore the point part and is already going to take a floor value. Okay, so integer merge a p q and merge sort again a q plus 1 to r, and fine, and then I'm just going to call the merge function, that is a merge on a comma p comma q comma r. So this is the merge function. This is how the merge sort function is going to work. Now for this merge sort function to work, we have to create the skeleton of the merge function, and a part of this we are also going to have our main function. So assuming that this is our main function, so we'll be having integer main, and here in this integer main return we are going to just return 0. Okay, now let us see the merge function. So in the merge function we have what was our implementation is, this is an array like this from p to q and q plus 1 to r. From p to q the data is already sorted, and q plus 1 to r the data is already sorted. So to identify how many values are between p to q, so it will be q minus p plus 1. Okay, for example, if the index locations are as like this 3 4 5 6 7 8 9 and 10 and 11, assume if these are the index locations. Now if you want to identify how many values are there between p to q, for that purposes we are going to take 6 minus 3 plus 1. 6 minus 3 plus 1 is 3, because I've taken this 6, I've taken this 3, 6 minus 3 plus 1, so it will be equal to 6 minus 3 is equal to 3 and 3 plus 1 is equal to 4. So you can see 1 2 3 4, there are 4 values between p and q. And if I want to find how many values are between q plus 1 to r, that will be r minus q plus 1 plus 1, so which will be equal to r minus q minus 1 plus 1, which is equal to r minus q. If you are just going to do r minus q, then you are going to identify how many values are between q plus 1 to r. So the value of r is 11, the value of q is 6, so 11 minus 6 is equal to 5. So you can see there are 1 2 3 4 5, there are 5 values here in this location. Okay, so we are just going to do it like this. Now this is 5, correct. So now we are going to implement it. So how to implement it? You have to copy these values to a new array, you have to copy these values to a new array, and you have to merge it back, right? But when you are going to copy these values to a new array, now here in this array you can take a very huge value in the last index location, you have to take one index location as extra. Again here also you can take the one index location as extra. Actually, why we are taking this infinity and the last location? Because it will be easier to implement, right? Without even taking this infinity you can do it properly and there is no issues whatsoever. Okay, you will not be facing any issues, but you have to take those conditions into consideration, that if you are copying the values from this array and there are some values which are still remaining in this array, now if this array is already finished, so then we have to copy all the values from this remaining array. Okay, this thing should be taken in consideration. So but still I'm just going to let us do one thing. Let us try to see if we can implement it without using the infinity value, because using this infinity value means if it is an integer array then you have to take the largest integer value, but with a random function that largest integer value is still possible while implementing this function. So I'll just try to implement this merge function without using this infinity value here. Okay, so there are multiple ways of implementing this, but let us try to first of all figure out our strategy. We'll be having this array, so we'll take some random values. So assuming that these are the index locations, okay, and the index locations are 3 4 5 6 7 8 9 and 10, and the values inside this array is 4 5 7 9 1 3 4 5, assuming these are the values which are present inside this array. Now this one more thing what I can do is I can take one more array exactly like this, which is having the index locations like this, but better is just let us do one thing, let us implement inside the same array. So instead of taking one more array, oh sorry, but anyways, okay, I just, yeah, so instead of taking one more array, I'll just try to implement it inside the same array. Okay, so let us try to see if we can implement it inside the same array. That means I have to take this array which is having 4 index locations. Instead of taking 5 index locations, I'm taking 4 index locations. So we'll be copying this data 4, 5, 7 and 9, and we'll be copying 1, 3, 4 and 5. Now we have to take 3 pointers here. We'll be taking a pointer k, we'll be taking a pointer I, and we'll be taking a pointer j. Now we have to see if I is less than j, then we have to copy this data. But you can see if j is less than I, so we have to copy the data which is pointed by j. So 1 will come here, then we are going to increment the value of j. Now 3 is there, 3 is less than 4, so 3 will come here. Now we are going to increment the value of j. Now 4 is less than or equal to 4, so I'm just going to copy this 4 here, and I'm going to increment the value of I. Now this 4 is less than 5, so I'm going to copy 4 here, and I'm going to increment the value of j. Now this 5 is less than or equal to 5, so I'm just going to copy this value in here, and I'm going to increment the value of I. So I is pointing to 7. Now because 5 is less than 7, I'm going to copy this 5 here, and I'm going to increment the value of j. Now you can see if j is pointing to a location which is outside the range of this array. For example, here in this array we are having 4 values. If j is pointing to index location which is greater than this, that means here in this array we'll be having index locations which are 0, 1, 2, 3 and 4. If j is pointing to 4, in that case we have to copy all the data which is present inside this array to this array. Okay, otherwise if I is pointing to the last index location, then we have to copy the data which is present inside this array to this array. Okay, this can be a very good strategy for this. Okay, so let us try to see if we can implement it. Either I can do, I have two choices actually. So I can implement it very easily, there is no problem with it. But my options, what I want to do is I want to make these videos so simple to understand that you don't have to learn any new concept. Okay, so maybe I can implement the same functions again, but let me think. I can implement this one or that one. I'm very confused now onto this. So let us do one thing. Let us go back to this original implementations, and let us see. While we're trying to see, let us figure it out. So I'm just going to take integer. They should be. We have to see what is the size of the left and the right array. So integer, we have to take number n1. And we have to take the number which is n2. n1 is the size of the left array, n2 is the size of the right array. So n1 is equal to q minus p plus 1, and n2 is equal to we'll be having r minus q. Okay, now we have to create two arrays which are the left array and the right array, but because C language does not support dynamic memory allocation, therefore we have to use the malloc function. So I'm going to create a malloc function, but for malloc function I have to include the header file which is #include stdlib.h. So this is the header file that we have to include. After including this header file, now we have in the merge function, so we have these header files. Now we have to create the left and the right array which should be having a size which is greater than the original size. So I'm going to take integer star left is equal to, this is the left array, integer star, this is for dynamic allocation, dynamic memory allocation, malloc size of integer multiplied by n1 plus 1, because we have to create a size which is greater than the original size. So this is actually the original implementation. Then we have to take integer right array, so I'm going to integer star right is equal to integer star, and we'll be having malloc size of integer multiplied by n2 plus 1. This is just a implementation of this. Okay, now we have the left array which is greater than this, and right array is there. So we have to, in the last index locations, by the way, how many index locations will be there in the left array? Index locations will be 0 to n1, because size is n1 plus 1, right? So 0 to n1, there will be index location in the left array, and at the same time in the right array the index locations will be from 0 to n2. Okay, so in the last index location in the left, so left of n1 for the left array at the index location which is n1, I have to store a very huge value. So here we have to see what is the max value for integer, max variable size or max value. Okay, so is there any function which is already there for the max value? I'm just going to use it. So let me do a Google search on this. I'm just going to include this header file because it will be very convenient to use it. So I'm just going to use this function which is int max to store the integer maximum value for the integer. So I'm going to use int max, as well as for the right array. So right with n2 index location, I'm going to use int max, maximum index maximum value. Now we have to copy all the data from the original array to the new array. Okay, that means to say what we have done till now. Here we were having originally we were having an array. So what we have done till now, we have taken two new arrays, which is left array and which is right array. Left array is having index location 0, 1, 2 up to so on n1, and right array is having index location 0, 1, 2 up to so on n2. Now in the last index location we have stored a very big values. Okay, now here in the rest of the all index locations we have to copy data from the original array. This is the original array. So we have to copy data from P to Q into this array, and we have to copy data from Q plus 1 to R into this array. So to copy the data from the left array, I'm going to create a different for loop, as well as to copy from the data from the right side, we have to create a different for loop. So for the left side, I'm going to write for integer I is equal to P and or I less than or equal to Q, and we'll be having I plus plus. I just have to copy this data. So left of I minus P is equal to A of I. So this is how you can copy from the left array, as well as for the right array. For integer j, make it for integer, make it again j is equal to better than this is better than creating these variables again and again. So I just create these variable one time only. So I'm just take integer I comma j comma k. I just take three variables like this. So I'm going to take j is equal to q plus 1 to j less than equal to r, and I'm going to do j plus plus, and then after this I'm going to write right of j minus q, right of j minus q minus 1. It will be correct. Right of j is equal to q plus 1, so we have to start right of 0. So minus 1 is cutting this one, and correct. So this is the value, then is equal to, this will be equal to a of j. So these are the values that we'll be having. After this, because from these two for loops I just copied the values from the left and the right array. Now I'm just again going to initialize the value of I is equal to 0 and the value of j is equal to 0. Okay, now again I'm just going to do the same thing. For k is equal to p and k is less than or equal to r and k plus plus, then I'm going to copy the data. So if a of k is less than, or instead of I have to take if left of I is less than or equal to right of j, then I have to increment I, so I have to do I plus plus, and I have to do a of k is equal to left of I, left of I. So this is there, as well as else we have to copy from the right array. So it will be actually I have to increment the value of I later on. Instead of incrementing it here, I have to do it in the next line after this, after copying the values. So I have to do a of k is equal to right of j, and I can just do j plus plus. That will be better. So it will be combining these two statements together. Okay, so this is the merge function and this is a merge sort function. We have already implemented the merge function as well as the merge sort function. Now we are just going to see if it is working perfectly or not. So I have to take integer variable, integer a, which is having 10 locations, and we have to give some values, assuming the values are 5, 7, 3, 4, 8, 0, 1, 9, 2, and we'll be having a value 6. So how many values are there? These are 4 plus 4 plus 2. So these are total 10 values. Now I have to call this function, which is merge sort on a comma 0 to 9, and this time I'm just going to print these values for the for loop. For integer I is equal to 0, I less than 10, and we'll be having printf percentage d space comma a of I plus plus. So using this for loop, we are just going to print these values. So let us try to see if it is working perfectly. So let us see. Fingers crossed on this. Okay, so we got an error. So error is, we don't know, it does not know what is the variable q. Okay, and do we have any other error? So okay, fine, you can see it is working correctly. It is sorting the data and it is working correctly, as you can see clearly here. We did not face, the only minor bug was that, only minor issue was we have not declared this variable q, and I'm just going to build and run again, and you can see it is working correctly. There's no problems. Okay, so I hope this is clear to you how I implemented this function. Okay, so now I'm going to copy this function in that insertion sort program, and I'm just going to compare all these algorithms again in terms of time complexity. So I'm just going to copy, Control plus C, and I'm just going to implement it here. So after this quick sort program, I'm going to write the insertion sort program, and again I'm going to copy the same values here so that we can compare the insertion sort program with the other values. So this is for the insertion sort. Sorry, this is for the I'm very bad with the names. This is for the merge sort algorithm. So in the merge sort, we'll be calling this function, and again this will be the merge sort function. So it is merge sort. As remember, the time complexity of merge sort is also order of log n. So just going to debug, build and run, and again, so it is saying there is problem. Okay, so we have to include the header file, which is limit.h. So again, I'm going to include these header files, which is limits.h. I'm going to build and run. Okay, now you can see the time taken by insertion sort function is 82 milliseconds. The time taken by the improved bubble sort function is 340 milliseconds. The time taken by selection sort function is 136 milliseconds. The time taken by quick sort is 1 millisecond, and time taken by merge sort is 3 milliseconds. Now you can clearly see how we compared all these 4 algorithms, and how we got, this is very interesting, right? Because you can clearly see by your own eyes that how the time complexities are affecting these how the program running time is affected by this one. Okay, with this also we can also see how much stack space is utilized, because there is a space complexity, and we can even do a reverse engineering onto this program. If you want me to do reverse engineering, just let me know. Okay, so we can do a reverse engineering onto this program while executing this program, and we can see how much stack space is also utilized. Okay, so it is actually possible for every program to do a reverse engineering for the C language, because C language gives so much facility for us, and we have on using this GCC compiler, it is possible. Okay, so you can see how interesting this was to implement all these algorithms, and seeing how these algorithms are compared in terms of time complexities, and by seeing the lifetime. Okay, now I'm also going to compare some of the searching algorithms, because there are some searching algorithms like linear search is there, a part of linear search, binary search is there, a part of binary search, there are more searching algorithms are also there. So in the next videos we are also going to compare those searching algorithms in terms of time complexity and space complexity. A part of this one, I will just give you as a homework. Please try and implement the radix sort function and the bucket sort function in the programs. So I've taken these traditional sorting programs, and these I've implemented them. I'm just going to give you a program for the bucket sort as well as the radix sort, but you understand the concept of radix sort. I think I've already explained in some videos, so you just try to implement the bucket sort and the radix sort. So for this video, I'm just going to finish this video here, and I hope this session was productive for you. All the best, and let us move on to the next part here. Okay.